this is the actual aspect of the RenewIT tool. The RenewIT tool is divided in 6 different stages, as you can see here. As I said before, at the beginning, we ask to the user preliminary information of the data center, so the general information and IT infrastructure information. Then we ask for power and cooling systems, so how we supply electricity and how we supply cooling energy to the data center. Then energy characterization in terms of, do I have any advanced electrical or thermal energy system like modular UPS or like variable airflow through the white space, etc. Later on we will see. And as I said before, if you want to evaluate economically and energetically what happens if we put PV or wind turbines in the data center. And then at the end, the stage number 5 is just a summary of all the information that the user has filled in to the graphical user interface, and then we will see the results. Okay, so imagine that I want to evaluate a data center, let's say in Stockholm. So I just have to select the location here. Now we have more than 30 locations, which represents all the climates in Europe. Okay, so I cannot evaluate, for instance, Granada, but Granada and Seville, the climate is more or less the same. Okay, so the climate is all fulfilled, let's say. Once you have selected the location of your data center, by default, we provide real data of the electricity cost in that location, real data of the percentage of renewables in the grid, okay, and then we ask to the user the assessment period. So imagine that I want to evaluate the data center for 15 years. The user is able to change everything. So imagine that in 2 years, the renewables energy in Sweden, so we can increase or decrease this one. And for advanced users, we have these options that the user can change. For instance, if I want to account for the price of the CO2 emissions, this one is the standard price for Sweden, but I can change as well this one. This one. Okay, or if I want to change the CO2 emission factor, so I can change this one. But this is for advanced users. So going back, I just want to evaluate a data center in Stockholm. So just select Stockholm and next stage. So IT infrastructure. Here I have to introduce which kind of IT load profile do I have. And nowadays, imagine that I have a HPC workload in a data center of 1,000 kilowatts of IT. This IT safety margin is just for design phases. The occupancy ratio, I guess, I have almost all the data center full, and average rack density is 5 kilowatts per rack. It's okay. Here we ask if the user wants to implement any green algorithms, as I said before, consolidation or IT scheduling. In this case, we can avoid that. Then I have to select how we provide power and cooling to the data center. In this first system, I will obviously implement hot and cold ice containment. And then we came out with energy characterization, as I said before. If I want any electrical energy efficiency strategies in terms of UPS, or standard UPS, or modular UPS, or bypass UPS, we can go with the standard one. Then we can play with the size of the power converter of the UPS in order to control the reactive power. That would be the same effect that if we put some capacitance in the electric systems. Then we also can introduce some thermal energy efficiency strategies. So imagine that I want to change the inlet air temperature to 24. I can change it. I want to increase the white space delta T, so in every single stage, I can just go to the information button and I can read what it does mean. So enhance of the air management performance, so increment from a delta T, so the difference of the temperature difference between the return air temperature and the supply is 7, but if I select this one, it will be 15, okay? And then I will implement variable airflow. In this case, I don't implement any renewable at all, just next. As I said before, this is just a summary of what I have chosen. Here it's all the information related to this case, and just press the calculation button. So now, if you imagine the structure, now we are running some pre-processing info. We run the meta models, some post-processing, and now we show the results. Okay, these are the results for scenario 1, as you can see here. Another time, some information about what I have selected, and here we show first absolute results. Okay, in terms of energy use, we are using primary energy consumption over the 15 years. Primary energy divided by the IT capacity. Some economical figures, so the TCO, CAPEX, and OPEX. Some capacity analysis, so the space, the available space, etc. Then energy efficiencies and renewable energy, so some indicators, so the PUE, the cooling seasonal performance factor, and the renewable energy ratio. Okay. And then we also show some relative results. So if we compare the actual scenario, which is located in Stockholm, 1,000 kilowatts of IT power, with a conventional system, but we have implemented, as you remember, some free cooling, and we have implemented some thermal advanced concepts, but we compare this with state-of-the-art scenario, obviously with no free cooling. Okay. And here we show the relative results if we compare to the state-of-the-art. So the primary energy savings are up to 23%. I just to highlight that the results are not the 100% version, let's say. We are still improving the meta models behind the RenewIT tool. So at this stage, probably these results are not 100% correct. Here we also show one comparison in order to understand what does it mean, this primary energy savings. So it means that we save the energy consumed by 2,000 houses. Okay. Or we show as well the TCO savings in comparison with the state-of-the-art case and the payback period. This process can be done up to 5 times at the same time, let's say. So now I have the scenario 1. If I press here, I start again. Sorry, I start again, but notice scenario 2. So imagine that I want to evaluate not in Stockholm, but the same data center, but in Madrid. So I change to Madrid. Obviously, all this data, which is related to price of the electricity in Spain, the kind of renewables, etc., is automatically changed. And then I just go ahead. All the data that I have introduced before, it's exactly the same. Okay. So I don't want to change anything. I just want to, for instance, I want to implement some PV on the roof of my data center. So we can we can put PV, but we can put PV in 2 different ways. So if the user knows the area available, so imagine I have 4,000 square meters, automatically we give some idea of the PV peak power, but at the end of, obviously, when we run the meta models, then we will get the correct value. And in Madrid, there is no wind, so there is no option to put wind. If I put wind, and the system will calculate, but obviously probably the economical figure will be really bad. So another time, the summary in this case, I changed to Madrid, conventional system, exactly the same as before. So I have increased the free cooling, and I increased the temperature, the inlet air temperature, etc. And just press calculate button. Now we have the results for this scenario 2. Exactly the same results as before in terms of metrics, but obviously different numbers. Okay. Moreover, we have these two different tabs here. If you remember, at the first running, when we only had scenario 1, we didn't have this because this is to compare different scenarios between each other. Okay. So if I go, for instance, to advanced comparison, I can compare the absolute values between the scenario 1, which is located in Stockholm, and the scenario 2, which is located in Madrid. Okay, so in terms of non-renewable primary energy, TCO, PUE, etc. Okay, and then now it has, and then we also can compare relative comparison. So now there is no, we only can compare scenario 1 with the scenario 2, but remember that we can do this task up to 5, so we can compare up to different scenarios between each other. So in this case, if I compare scenario 1 with 2, here, scenario A, which is in the Stockholm, is the reference case, and we compare the scenario 2, which is in Madrid, with this data center in Stockholm. Okay, some figures are wrong in terms of there is no from energy and economical point of view, there is no option to go to Madrid, so you will go to Stockholm in this case. Okay, but we can compare in the other way around. For instance, sorry, I can change this. Okay, if I compare the Stockholm data center with the Madrid data center, I can see that having the same IT consumption, etc., it's better for me to go to Stockholm. Okay, so that's the idea, the main idea. I hope that you have get not a clear and deep information about the RenewIT tool, but using this information, and once we have ready the demo, the video demo, I say, you can have the chance to play with the tool and obviously give us some valuable feedback. So in terms of, I don't like to ask for, I don't know, I don't like to ask the green algorithms in the IT infrastructure. It could be in the energy characterization, or I don't understand what is IT safety margin factor, etc. A part of any valuable input regarding the results, the energy results, or the economical results.